In general, the formula for the size of the union of two sets is that the size of A union B is the size of A plus the size of B minus the size of their intersection. If the size of their intersection is 0, then we have that the size of their union is just the sum of their two parts. This is the scenario where A and B have no overlap. If they have no overlap, then we say that the two sets are disjoint. In our first introduction to probability, we saw at least one scenario where we are going to have to know how many outcomes an experiment might have. The number of outcomes of many complicated experiments can be counted by classifying parts of the problem as either unions of disjoint sets or as the Cartesian product of sets. Here we have two small examples of the question of how many orders are possible. In the first scenario, part of your meal requires the choice of one soup from 4 options or one salad from 3 options. Our second scenario is at an ice cream store, which requires choosing one of 3 sizes and then one of 2 flavors. At the restaurant, the first decision we have to make is to choose soup or to choose salad. We're told that there are 4 soups to choose from, or we could choose one of the 3 salads. In total, we can count that there were 7 ways to order, and that this 7 ways to order is equal to the number of soups plus the number of salads. In this first scenario, we added the number of options for soups to the number of options of salads. In our second scenario, our first question is to choose a size. There were 3 sizes available. Then we were to choose a flavor. For our first size, there were 2 flavors we could have chosen. For our second choice, there was still 2 choices of flavor. And again, for our third choice of size, there were still 2 choices of flavors. There ends up being 6 possible orders. Here, our 6 is equal to the number of sizes times the number of flavors. Our first scenario is going to be our example for the additive principle. The additive principle is that the size of the union of 2 disjoint sets is the sum of the size of each set. In the first scenario, we employ the additive principle because we're trying to choose between soup or a salad. That or clues us in that we're trying to do one or the other. We're not trying to do one and then another. So it's this notion of union. And here we'd infer that these 2 sets are disjoint because it's a reasonable assumption that there are no soup salads. Our second scenario will be our example of the multiplicative principle. Here the multiplicative principle is that the size of the Cartesian product of 2 sets is the product of the sizes of those 2 sets, i.e. that we multiply the number of options for each step. Here we're clued into it because we know that we need to make a choice of size and also make a choice of flavor, and that we'll do one and then we'll do the other. The first, there are 3 options, and then the next, there are 2 options. So we multiply 3 times 2, and we get 6.